For decades, the physical act of writing software has operated entirely on what you could call an all-you-can-eat buffet model.
Right. Yeah, like a flat fee.
Exactly. You buy a decent laptop, you download a code editor, maybe set up a local environment, and then you just type.
And that's it.
Yeah. Whether you solve a really complex architectural problem in 20 minutes, or you spend like 3 agonizing days rewriting the exact same 50 lines of CSS to center a div in.
We've all been there.
Right. But the fundamental cost of your tooling, it doesn't change.
No, the overhead is fixed. I mean, once the hardware is sitting on your desk, your compiler doesn't charge you a premium for being inefficient or, indecisive.
But the moment you integrate agentic AI coding tools into your workflow, that buffet gets abruptly boarded up.
Totally boarded up.
It's like we're suddenly operating in an environment that feels a lot more like sitting in a taxi in gridlock traffic and just watching the meter tick up.
That's a perfect analogy. It is a radical shift in the underlying economics of software development.
Right.
Because you're no longer just paying for your own time. You are literally paying for every single thought process the machine executes, every file it searches for, and every mistaken path it wanders down.
And mastering that new economic reality is our mission for today's deep dive. We're going to figure out how to, stop the meter from spinning out of control.
It's so necessary right now.
It really is. So I was digging into some brand new documentation, Anthropic, just published today, August 14th, 2026, by Lydia Halley.
Oh, yeah. Brilliant post.
It really is. It's titled Maximizing the Value of Your Claude Code Sessions. And it basically pulls back the curtain on how these tools actually process our requests and consequently how they bill us.
And the architecture she outlines is just fascinating because, well, it forces developers to think about computing constraints in a way most of us really haven't had to since the early days of memory management.
Okay, let's unpack this. The core premise is that with agentic tools, the exact same task can have 2 completely different price tags depending on your behavior, right? Like, you could ask Claude to fix a bug, and I could ask Claude to fix the exact same bug, and my request might cost like 10 times more, simply because of the way I manage the AI's context.
Exactly. And if we connect this to the bigger picture, being efficient in this new paradigm, it doesn't mean restricting the AI's capabilities.
Right. You're not trying to dumb it down.
No, you aren't trying to lobotomize the tool just to save a few pennies. True efficiency means ensuring your tokens, which are the literal currency of this environment, are being spent solely on solving your core problem.
Rather than forcing the model to churn through irrelevant files or process noisy background tasks.
Precisely. You want it focused.
So to really control that spend, I think we have to look at what a token actually represents physically.
Yeah.
Because we talk about tokens like they are arcade coins or something.
Yeah, virtual currency.
Right, but they are tied to raw hardware.
They absolutely are. To grasp the economics, you have to look at the silicon. When you are billed for a token, you are paying for inference. That is the literal fraction of a second it takes a GPU or a specialized TTU cluster to perform massive matrix multiplications to process your data.
Okay, so the way I've been visualizing it, and let's see if this holds up, is that hiring an AI agent is somewhat like hiring a general contractor for a home renovation.
I like where this is going.
But this contractor has a very strange billing structure. They charge you one rate for the time it takes them to sit at a desk and read over your architectural blueprints.
Right, the preparation phase.
Exactly. That's the input. And then they charge you a drastically higher rate for the actual physical labor of swinging the hammer and building the walls.
Yeah.
That's the output.
That is a highly functional way to visualize the architecture of a large language model. Any request you make goes through the hardware in 2 distinct phases.
Okay.
The first is the prefill phase. This is your contractor reading the blueprints. The model ingests your system prompt, your custom instructions from your claude.md file, the tool definitions, and your entire conversation history.
So it's absorbing the entire context of the job site before it makes a single move.
Correct. It processes all of those input tokens to understand the current state of the world. And once that prefill is done, it moves to the decode phase.
The hammer swinging.
Exactly, the output. This is where the AI actually generates its thinking, makes decisions to call specific tools, and writes the code or text that appears on your screen.
Right.
And the architectural constraint that dictates the price difference here is that the decode phase happens sequentially, one single token at a time.
Wait, I want to pause on that. Sequential.
Yes, strictly sequential.
So if the model generates a 500-word explanation for a bug it found, it's not just spitting out 500 words at once.
No, not at all. It's running through the entire neural network, predicting one token, and then running through the entire network again to predict the next one.
Wow.
Exactly. The GPU can process your thousands of input tokens in the prefill phase in massive parallel chunks. It's incredibly fast.
Oh, because it already has all the text provided.
Right. But generating output requires feeding the previous token back into the model to guess the next one. It's a sequential bottleneck.
That sounds incredibly resource intensive.
It is. That decode phase keeps the hardware occupied for a significantly longer duration, which is why output tokens are priced at roughly 5 times the cost of input tokens.
5 times. Okay, I'm going to push back here because as a developer, that sounds like a trap.
A trap? How so?
Well, if output is so disproportionately expensive, and the AI is constantly generating these invisible thinking tokens in the background to reason through a problem, how do I stop it from bankrupting me?
Ah, I see what you mean.
Like, what if I just need to do something totally mundane, like alphabetize a massive JSON configuration file? I don't want it spending 5x premium tokens having an existential crisis over a missing comma,
That is a very real risk if you just leave the agent on autopilot. The solution is taking explicit control of the model's parameters.
Okay, how do we do that?
Anthropic provides a /effort command for this exact reason. You dictate how deeply the model is allowed to ponder before it acts.
So I can manually throttle the internal reasoning?
You can. And for the scenario you just described, like mindless formatting or data translation, you can deploy an extreme configuration
Which is?
by setting the environment variable max thinking tokens to 0.
Oh, wow. Literally 0.
Literally 0. You effectively bypass the extended reasoning loops entirely. The model skips the deep pondering and just executes the formatting, which drastically reduces your output costs.
That makes total sense for grunt work.
Yeah.
But even if we aggressively throttle our output, we are still constantly sending massive amounts of context on the input side.
True.
If output is the hammer, input is the blueprint, and those blueprints get longer with every single message, how do we keep the input costs from scaling out of control?
This brings us to what is arguably the most critical engineering feat in modern LLM infrastructure, which is prompt caching.
Yes.
Without it, agentic coding would just be financially unviable for most developers.
Here's where it gets really interesting. The Anthropic documentation notes that if your input tokens are read from the cache instead of being processed from scratch, you get a 90% discount.
It's massive.
Yeah, you're paying 0.1 times the base price.
It's a staggering discount because of the compute you are saving the provider. If your tokens are cached, the server doesn't have to recalculate the attention matrices for that text.
It just remembers it.
Basically, yeah. It just loads the pre-computed mathematical state directly from active memory. But to understand why this discount is the difference between a $5 session and a $50 session, we have to look at how the API actually handles a multi-step conversation.
Let's play out a scenario, because I think a lot of people, myself included sometimes, assume these tools work like a continuous phone call.
Where the AI just remembers what you said 5 minutes ago.
Exactly.
That is the most common misconception. In reality, the API is entirely stateless.
Okay, so imagine I open my terminal and I get Claude Code, a seemingly simple prompt like, fix the failing test in my utility file. Visually, I hit enter once, but what is the client actually doing under the surface?
Under the surface, the client initiates a remarkably complex lifecycle. On your initial prompt, Claude Code packages everything. Your system prompt, the tool definitions, and your command to fix the test.
Right.
It sends that massive payload to the server. Since this is the first turn, none of this exists in the cache yet.
So no discount.
No discount.
Yeah.
You pay full price for the prefill, and the server writes that computed state into the cache.
Okay, the foundation is laid. Full price.
Yeah.
But the AI doesn't know what's in the utility file yet, right? So it has to ask to see it.
Right. The model outputs a tool call to read the file. Claude Code, running locally on your machine, executes that read, appends the contents of the file to your conversation history, and here is the kicker.
Oh boy.
Because the API is stateless, Claude Code has to send the entire history back to the server again.
So it's resending the system prompt, the tool definitions, my original request, plus the new file contents.
Yes. But this time, the server recognizes the first chunk of your payload. It pulls all of that foundational context from the cache at a 90% discount.
That's amazing.
It is. You only pay full price to pre-fill the new text, so just the file contents that were just appended.
I'm seeing the compounding nature of this. So next, the AI realizes, Okay, I see the test, but I need the actual source code to fix it.
Right, it needs the implementation.
Right. So it outputs another read request. The local client grabs the source code, tacks it onto the bottom of the payload, and sends the whole gigantic package back over the wire.
And again, the cache saves you. Everything from the previous turns is loaded from memory at a fraction of a cent, and you only pay the premium to ingest the newly attached source code.
And this cycle just continues.
Exactly. The AI writes the edit, sends the payload, it runs the test suite, appends the results, sends the payload.
It's like having a conversation where before you can make your next point, you have to recite every single word you both have said since the moment you met. If we were paying full price for that compounding history on every single turn, the costs would be astronomical. The cache is basically a financial shield.
It is a shield, but it is an incredibly fragile one.
Yeah.
And that fragility is where developers unknowingly hemorrhage money.
Because the cache isn't just a bucket of text that the server, fuzzy matches. It's strictly sequential.
Very strict.
I've been thinking about it like a giant Jenga tower. The cache matches from the absolute top of the payload downward. Tool definitions, then system prompt, then the conversation history, block by block.
Perfect analogy.
If you alter or remove a block at the bottom of the tower, the whole thing instantly collapses, and you are forced to rebuild the entire context window at full pre-fill price.
What's fascinating here is how seemingly innocuous developer habits act as severe cache busters.
Yeah.
The cache key on the server side is tied to very specific parameters of your request. Altering those parameters mid-stride destroys the alignment.
Let's talk about those cache busters, because I know I've triggered them without realizing it. Say I'm 40 turns deep into a gnarly, complex debugging session.
Okay.
The context window is huge. I'm getting frustrated because the model isn't grasping the logic, so I decide to switch to a smarter, larger model. Or maybe I crank up the effort slider to force it to think harder.
The moment you do either of those things, you've altered the underlying cache key.
Just like that.
Just like that. Every model has its own distinct, isolated cache architecture, and the effort level parameter is baked directly into that key.
Yeah.
When you send your next turn, the server looks at the payload, sees a parameter mismatch, and rejects the cached state. Your entire 40-turn history gets processed from scratch at full input price.
That is brutal. Okay, what about the speed toggles? There's a fast mode you can use for quicker, less complex iterations. Does toggling that midstream break the tower?
Fast mode alters the routing, so yes, turning it on mid-conversation will absolutely bypass your established cache.
Good to know.
Interestingly, though, the Anthropic engineers note that turning it off mid-session is generally safe regarding the cache. But as a rule of thumb, if you want speed, initialize it at the very start.
Now, here is a scenario I run into constantly. The AI goes down a rabbit hole, gets confused, and generates 5 or 6 turns of absolute garbage.
It happens.
Right. I want to clean up the context window. The documentation mentions a /compact command. If I run that to summarize the mess, does that save my cache?
This is a crucial area of confusion. Running /compact is devastating to your cache.
Wait, why? It's making the history smaller.
Because it achieves that smaller size by using an LLM to dynamically rewrite and summarize your conversation history.
Oh.
It changes the actual text. If the text changes, nothing matches the prefix the server holds in memory. The Jenga tower falls.
Oh, I see. Because it's not the same history anymore. It's a summary of the history.
Exactly.
So I'm paying full price to pre-fill the summary. Is there a way to undo a mistake without destroying the foundation?
Yes. Instead of compacting, you use the /rewind command.
How does that bypass the cache issue?
Because of how the prefix matching works, if the Jenga tower is built from the bottom up, the most recent turns are at the very top.
Right.
The /rewind command doesn't rewrite anything. It simply chops off the top blocks of the tower. It drops the last few bad turns entirely.
Oh, that's smart.
The foundation underneath remains identical to what the server has in memory, meaning everything before the rewind is perfectly preserved in the cache.
That is a brilliant distinction. So truncation preserves the cache, summarization destroys it.
Correct.
But there's one more cache buster we have to mention, and it doesn't even require you to touch the keyboard. Time.
Time is the silent killer of the prompt cache. The servers physically cannot hold infinite states in active memory. If you are on a standard API tier, your cache sits there for exactly 5 minutes.
5 minutes. So if I trigger a test suite, go to the kitchen to grab a coffee, chat with a coworker, and come back to resume the session.
The cache has been evicted from the server's memory. Your next prompt will trigger a full, undiscounted pre-fill of the entire accumulated history.
Wow.
If you are on a higher tier subscription, that window extends to an hour. which is far more forgiving, but it still requires mindfulness. You can't leave a session open overnight and expect a cheap resume in the morning.
Okay, so we've established how to keep the Jenga tower standing. But even if we flawlessly maintain the cache, the sheer size of the context we're dragging around dictates the overall cost.
Think of the context window as the cumulative burden the model is forced to carry.
I picture it like a hiker's backpack.
Yeah.
Every time the AI opens a file, reads a document, or executes a terminal command, the output gets shoved into the backpack.
Yeah.
By turn 40, you are paying the model to lug around the baggage of the previous 39 turns on every single step.
And a huge contributor to that weight is what this post implies is a read tax.
The read tax.
The read tax is an excellent way to conceptualize the friction of vague instructions. If you tell the agent, like, my database tests are failing, please investigate, you haven't given it a starting coordinate.
Right, so it has to go hunting.
Exactly. The agent has to output a command to execute a global grep search. That search returns a list of files.
More tokens.
It reads the list. Then it outputs a command to open the 3 most likely files. It scans them, realizes 2 are irrelevant, and finally focuses on the 3rd.
And all of that goes in the backpack.
Every single search result, every irrelevant file, and every step of that hunting process gets permanently stuffed into the context window. You are carrying that dead weight for the rest of the session.
But the documentation provides this incredibly simple hack to entirely bypass the read tax. It's the @ symbol trick.
Yes, the @ mention.
If I know exactly where the failure is, instead of typing check the utils test file, I literally just type @utils.test.toerec.t.
From a systems perspective, that @ symbol changes the routing entirely. When you @mention a file, the Claude Code client running on your machine intercepts it.
It doesn't even go to the model yet.
Right. It immediately grabs the contents of that file and injects it directly into the prefix of your very first message before anything is transmitted to the server.
So the AI never has to generate an output token asking to read it, and it never has to guess where it is. It's just sitting there in the blueprints on step 1.
And because it's injected on step 1, it is instantly integrated into the foundational cache. It's an elegant optimization.
It really is. But files aren't the only things we shove into the backpack. When I'm debugging, I rely heavily on the AI running commands. And this seems like an area where developers can accidentally sabotage their sessions.
This is perhaps the most insidious form of context bloat. When the AI executes a command, say, running your test suite or fetching a git log, whatever the terminal prints out, is scraped and appended to the conversation history, identical to a file.
Now, I know the client has some built-in safety nets. Like, if I run a command that accidentally dumps the entire contents of a massive database, the client intercepts anything over 30,000 characters.
Yeah.
It writes the massive dump to a background file and only shows the AI a tiny preview. So it stops the backpack from instantly tearing at the seams.
That safety net prevents catastrophic failures, yes. But the real danger isn't the 30,000 character dump. The danger is the slow bleed of the stuff that slips under the limit.
Like a test runner.
Precisely. Imagine you have a test suite that prints out a confirmation line for every passing test. 400 lines of test 1 passed, test 2 passed.
Oh, I've seen that so many times.
It easily comes in under the threshold. So those 400 lines of useless confirmation get appended to the context.
Oh.
If the AI runs the tests 3 times during a debug session, you now have 1,200 lines of dead weight permanently lodged in your conversation history, dragging down the cache and bloating the prefill.
So how do we stop that slow bleed? Do I just tell the AI to stop running tests?
No, you solve it preventatively. You engineer your environment for silence. You can place explicit instructions in your claude.md file dictating that whenever the agent invokes the test runner, it must append a quiet flag, like -- reporter equals dot.
That's clever.
It's a trivial change, but it forces the terminal to only output a single character per test rather than a full line. You strip hundreds of lines of noise before they ever reach the context window.
Okay, but what if the task itself is inherently unavoidably noisy?
Like what?
What if I literally need the AI to comb through 10,000 lines of server logs to find a specific sequence of panic errors? I can't quiet flag a server log. Am I just doomed to destroy my main context window?
If we connect this to the broader philosophy of agentic architecture, the solution to a fundamentally messy task is delegation. This is where you deploy subagents.
Subagents. So instead of making the main AI do the dirty work, we spin up a temporary worker.
Essentially, yes. You instruct Claude to initialize a subagent to handle the grep search through the server logs. The subagent is spun up with an entirely isolated context window. It has access to the system prompts and tools, but it does not inherit your main conversation history.
It's completely cordoned off.
Completely. It executes its own turns, it dumps thousands of lines of logs into its own isolated context, it rummages around, finds the error sequence, and then, this is the crucial part, when it finishes, that entire messy context window is simply discarded.
Oh, that's beautiful. So the subagent goes down into the muddy basement, does the plumbing, and the only thing that comes back upstairs into my main clean context window is the final pristine answer. Location of the bug.
Precisely. Now, you are still billed for the subagent's inference while it works, so you shouldn't use them for trivial searches.
Right, they aren't free.
But for heavy data extraction, it acts as a firewall for your primary cache. And Anthropic offers a fantastic optimization tip here.
What's that?
You can configure your environment so that subagents default to a faster, cheaper model like Claude Haiku or Sonnet.
So you use the premium model for the high-level architecture in the main session and the ultra-cheap model to do the noisy text scraping in the background. That is incredibly powerful.
It really changes how you approach complex problems.
So what does this all mean for you, the person actually sitting at the keyboard tomorrow morning? It seems clear that succeeding in this environment isn't just about crafting clever prompts anymore. It's about practicing what we might call rigorous session hygiene.
Session hygiene is the exact right mindset. You can no longer treat an IDE as an infinite, unstructured sandbox. You have to actively prune the workspace.
Meaning you don't drag the context of yesterday's database migration into today's UI redesign.
No, definitely not.
You aggressively use the /clear command between distinct tasks to wipe the slate clean and start a fresh cache. You use the /context command when you open a directory just to verify what hidden files or instructions are being silently loaded. It's about actively managing the AI's attention and its memory budget.
This raises a deeply important question, I think. Something really worth pondering as these tools become the default.
What's that?
Well, if the daily reality of software development is transitioning away from manually typing out syntax and moving heavily toward managing an AI agent's attention span, optimizing its context window, and balancing its token budget,
Yeah?
does the very definition of computer science need to evolve?
Are we moving from being writers of code to being curators of context?
It seems inevitable. In the near future, the most valuable, highly compensated developers might not be the ones who can write the most elegant sorting algorithm from scratch.
Because the AI can do that instantly.
Right. They might simply be the best context curators, the engineers who know exactly how to pack the AI's backpack with precisely the right amount of information without ever toppling the Jenga tower of the prompt cache.
It is a completely different foundational skill set. Moving from the freedom of the all-you-can-eat buffet to meticulously managing the routing and economics of the taxi meter. And that is definitely something for you to mull over the next time you open up your terminal and invite an agent in to write your code.